Hello everybody. In this module, we will cover one more important topic, ADAS sensor integration. Advanced driver assistance systems rely on a suite of sensors that work together to perceive the vehicle's surroundings, process data and enable features like adaptive cruise control, lane keeping assist, automatic emergency braking and more. The integration of these sensors into vehicle involves hardware placement, data fusion and communication with the vehicle's control systems. Now, in this session, we will have a detailed breakdown of how these sensors are integrated. First of all, let's discuss about the physical placement. The physical placement of radar. What is, of course, everybody knows what is radar, radio detection and ranging. The placement is typically mounted on the front grille, rear bumper, supports adaptive cruise control and collision avoidance, and side corners radar in the blind spot monitoring. Now, when I explain to you about the various ADAS functionalities and ADAS features, you have got a reasonable idea where exactly these radars are placed. Radars are typically placed on the front grille, in the front grille, right behind the front grille, so that it does not spoil the aesthetics. Next comes the LiDAR. LiDAR, of course, everybody knows light detection and ranging. Now, where is the LiDAR placed? It is placed on the roof for 360-degree coverage or integrated into headlights and bumpers, even high resolution mapping for parking assistance and pedestrian detection. This integrated into headlights and bumping is actually very state of art. It is not very much prevalent as of now. As of now, LiDAR is mostly placed on the roof itself. But as technology progresses, it may happen that it may get integrated into headlights and bumpers also. But as of now, keep in mind that LiDAR is basically predominantly placed on the roof. Next comes cameras. Cameras are the various types, as I explained, monocular, stereo and surround view. Now, behind the windshield, forward facing, side mirrors, rear view camera mounted near windshields or bumpers, they feed data to systems like lane keeping assist or traffic sign recognition. Okay, so this placement, again, I explained this placement on the various types of cameras during the ADAS functionalities. So based on that, by now you have gathered that majorly cameras are placed behind the windshield, which is forward facing. For the 360-degree cameras, side view mirrors and rear view mirror camera mounted near the windshields or bumpers, and they also feed data to systems like lane keeping assist and traffic sign recognition. Next comes ultrasonic sensors. Alright, ultrasonic sensors are usually placed on the bumpers and detect close range objects via sound waves, ideal for parking assistance and low speed maneuvers. Next comes the IMU, inertial measurement unit and wheel speed sensors. I did not explain much in importance because they are actually they are very important, but they are not exactly, how to say, very popular kind of sensors. But for topic's sake, you understand that they are usually embedded in the chassis of the chassis or near the wheels. Next comes the GPS and V2X placement, antenna or the roof are embedded in the infotainment system. So usually it is embedded in the infotainment system. Now this is how you navigate the maps or navigate your vehicle with the help of the maps. It may be Google Maps, or every country is nowadays releasing its own maps. For example, India is also releasing its new map called Navigant. So depending upon the type of maps you are using, the GPS is embedded in the infotainment system. Now let's see how all the sensors are integrated with the electrical and communication. So placement of the sensors is one thing, but they must be properly integrated with the electrical and communication. Now, wiring and powering supply. Sensors connect to the vehicle's electric system, and also with the help of uh, communication protocols, routing is also clearly done. Okay, and when it comes to ECU network, processor sensor data and make decisions. Okay, and next comes the domain controllers, high performance computers, which are, it may be NVIDIA Drive or Mobile IQ, fuse data for multiple sensors. Alright, so this communication of the ECUs with the domain controllers is extremely important so that it works seamlessly. Next comes the data fusion. And there are various types of data fusion. It may be centralized processing or algorithms used or redundancy. What is meant by centralized processing? Combines inputs from radar, lidar and cameras to create a cohesive environment model. This is called centralized processing. Next comes the algorithms used. Now there are some algorithms which automatically or very rapidly fuse the data from various sensors like Kalman filters or neural networks or Bayesian methods to resolve the conflict between the sensors. Next comes the redundancy. What is redundancy? If one sensor fails, others can compensate. For example, if for camera or object detection, both camera and radar are required, but due to some unfortunate situation or due to some unfortunate environment condition, that camera is blinded by the sun, then radar still detects the objects. Next comes the software integration. When it comes to software integration, middleware is very important because middleware connects the sensor data to the ADAS functions. It may be through AutoSAR or any other firmware software. Next comes the machine learning. AI models process camera images for object recognitions. So this is a very important, especially this machine learning and deep learning are drastically rampant in the automotive industry for software integration. And next comes OTA updates, allows remote software improvements for sensor performance. Vehicle actuation. Now what is meant by vehicle actuation? ADAS decisions are sent via CAN bus to brake control module, electric power steerings and throttle control. So these actuators are also integrated into the vehicle for sake of ADAS, because these actuators are the one which are actually executing the function. Okay, so these actuators are also integrated and connected to the entire ECU network so that they execute the required function. Now what are the various challenges in sensors integration? The biggest challenge is sensor interference. For example, radar signals can clash if not properly spaced. So if the radar signals can clash with some light signals or ultrasonic signals, if at all there is not proper spacing. Next comes the environment factors. Of course, these environment factors I already touched upon. Cameras may struggle in the fog or snowy conditions. LiDAR may struggle to perceive in heavy rain. Computational load and processing multi-sensor data requires powerful hardware and powerful processing units. Next comes the regulatory compliance. Sensors must meet safety standards. Okay, this is, I won't say this is exactly a challenge, but this is a legal necessity. And moreover, these regulatory compliances are becoming more and more stringent. So that is the reason, well, it can be perceived as a challenge also. Now let's briefly touch upon the ADAS sensor calibration. ADAS sensor calibration is process of precisely aligning and adjusting the sensors and cameras within a vehicle's advanced driver assistance systems to ensure they function correctly. This is very important. Identifying the sensor is one thing, placement is one thing, but third most important thing is it has to function correctly, accurately for a long duration. For example, in my car Hyundai i20, I bought this car in way back in 2016, but even today the sensors are perfectly calibrated. Whenever I take my car in the reverse gear, the drawing lines on the reverse camera where they clearly show the trajectory in which my car is being driven. Okay, so this shows the efficacy of the ADAS sensor calibration. And this is crucial because ADAS features like lane keeping assist, adaptive cruise control and blind spot monitoring rely on accurate sensor readings to assess the vehicle surroundings and assess the driver. Alright, now next comes the $1,000,000 question. How often do ADAS sensors need calibration and maintenance? Now this is highly subjective because I personally have seen sensors which are working perfectly accurately for almost 15 years without any need of any calibration. But auto OEMs, they always suggest that calibration should be done at regular intervals. First is, when is calibration required? Post accident or collision. Suppose even minor accidents such as fender benders or side swipes can misalign ADAS sensors, necessitating the calibration. Front end collisions often affect radar and cameras, while rear or side impacts may disrupt ultrasonic sensors or blind spot monitoring. Okay, so if at all there is a small accident, it may not be a very, how to say, totally vehicle damaging accident. Even a small accident like the bumper bending or the fender bending, it can necessitate or it can initiate the necessity to recalibrate the sensors placed on the bumper or the fender. Next comes the component repairs or replacement. For example, windshield is replaced. If windshield is replaced, naturally the cameras which are right behind the windshield needs to be calibrated. For example, suspension or wheel alignment work. Because the IMU is a sensor which is placed on the front axle or the rear axle. If at all the suspension or wheel alignment work is done, then IMU also must be calibrated. Next comes the routine maintenance. Regular servicing, including tire rotations or chassis adjustments, may trigger calibration needs for steering angle sensors or radar systems. Now, next comes the software updates. Updates to ADAS software can require calibration to ensure compatibility and proper operations. So even when software updates happen, then that also may necessitate recalibration, so that proper compatibility and proper operation is smoothly ensured. Next comes the system alerts. If ADAS warning lights are blinking or performance delays are observed, well, naturally recalibrate. No, this is more or less common sense, right? If ADAS warning lights are there, then naturally it has to be recalibrated. Now, what are the various maintenance considerations? The most important consideration is dynamic versus static calibration. The dynamic calibration involves testing sensors while the vehicle is in motion, and static calibration is performed in workshops with specialized equipment for precise alignment. Alright, so understand this sentence very carefully. Static calibration is performed in workshops, and this is a very important word. Static calibration is always performed in authorized workshop with specialized equipment for precise alignment. Okay, now but there are many built-in or plug-in alerts also. Many ADAS systems have built-in diagnostics that notify when calibration is necessary. Okay, so if at all there is some what you call disruption or misalignment, then there is like a onboard diagnostic. There are some ADAS diagnostics also which notify the driver that such and such a ADAS sensor needs to be calibrated. Next comes professional expertise. See, ADAS sensors cannot be calibrated by anybody. They must be authorized technicians, they must be certified technicians only with specialized tools to ensure proper alignment functionality, because there is something called a checkered box, there is something called a blinking screen. All these specialized tools and specialized equipment are required to ensure proper calibration is happening. Okay, thank you.